Okay, for this problem, you can solve it intuitively. This part was of 2 marks. Next part would be of 3 marks. So it's a 2 marks question. You can understand it's going to be little simple, easy. Because with intuition, you see, if the question is the angle of velocity of the ball with respect to trolley, then actually you go and sit on the trolley and think from there. And when you are sitting on the trolley, you're assuming that a trolley is stationary. When you sit on a train and you watch outside, you assume that you are stationary and the people outside are moving. That's the concept of relative velocity. That's a concept of different reference frame. When you sit somewhere, you think that you are stationary and other things are moving. That's how we feel. So when you go and sit on the trolley, you would think that the trolley is stationary and the rest of the world is moving. Now, if the ball, which has been started from origin, at all have to hit the trolley, and the trolley, when you are sitting on the trolley, you are thinking that trolley is stationary, then trolley is here. The trolley is not moving for you if you are sitting on the trolley. And if the ball has to hit the trolley at any stage of the journey, then the ball has to come straight to the trolley. When you are sitting on the trolley, you are thinking that trolley is stationary and the ball has been fired from origin and the ball is coming towards you. So in your reference frame, the ball is coming straight towards you. Then only it will hit you, because the ball is moving in a straight line. It is not going on a curvature. There is no acceleration to change the path. The ball would be moving in a straight line. And if the ball at all has to hit the trolley, it has to be coming directly towards you. So the angle that the ball will be making with respect to trolley would be 45 degree. It has to be 45 degree. If with respect to trolley, if the angle is any other angle, it's going to miss the trolley, because I told you, don't consider the dimension of trolley. Okay, so if it is any other angle more than or less than 45 degree, it will miss the trolley. If the ball has to hit the trolley, it has to go towards the trolley. Now, in the ground reference frame, if you fire it at angle of 45 degree, by the time it's going to come here, the trolley is going to move upward. Then it is not going to hit the trolley. Of course, in the ground reference frame, it has to be an angle greater than 45 degree. So that by the time it moves up, somewhere they moves, somewhere they meets, and the ball actually hits the trolley. So in the ground reference frame, the angle would be greater than 45 degree. But in the trolley reference frame, trolley is not moving. Trolley is not moving, trolley is stationary, and the ball is coming towards trolley. So in the reference frame of trolley, the angle of that the ball would be making with x-axis, that will be 45 degree. So this is the level of intuition that you should have. This is how the level with which you should understand the concept of relative velocity. Okay, so this is a good problem for your understanding, and I hope you should actually put your brain together to understand this. So this is from intuition. Now, intuition all the time may not work. So there should be a method, mathematical approach. When your mind stops working, still you should be able to solve problem. Now, mathematically, let's go about doing it. Let in the ground frame, the ball is fired at an angle phi. It is given that the ball is fired at an angle phi. So this angle is phi. Let the velocity be v. So that if you break the velocity into components, you will get v cos theta I cap plus v cos phi I cap plus v sin phi j cap. This is the velocity of the ball with respect to ground. Velocity of ball. Fine. The velocity of trolley is given as √3 minus 1. This is j cap. Okay. Now what we have to do is we have to find velocity of ball with respect to trolley. Okay. Velocity of ball with respect to trolley would be velocity of ball minus velocity of trolley. This is the only formula that we have studied in this topic, and rest everything comes out from this. Okay, velocity of ball is v. If you do it, you will get v cos phi minus √3 minus 1. This thing I cap plus v. Now you will get v cos phi I cap plus v sin phi minus √3 minus 1. This thing j cap. Okay, so this is what you have. Okay, now what is the angle? What is the angle that the velocity vector is making? The angle which the velocity vector is making, suppose that is with respect to trolley, that is suppose theta. Then tan theta is equal to, this is the velocity vector, this is the j component, this is the I component.